hello.
Yo, give a minute. There we have Maurice. Hello. From across the globe.
Oh man, it sounds like we have a full room almost.
Yes, it's a good scene here.
Oh, great. Great.
Yeah, we'll get started in a minute or so, Mary says.
Great. Whatever Mary says.
Exactly. All right, let's get started. You want me to begin, Maurice? Is there anything else you wanted to?
No, I mean, if it's okay, so I just would sort of introduce and sort of thank you, Robert, for leading us in this. I'm super excited to have both this technology and, more importantly, the expertise that Robert's been developing to support research that I think is making the Wharton Behavioral Lab, in collaboration with Wharton IT, the computing resources are so important that here we're making the Wharton Behavioral Lab really cutting edge. And I'm super appreciative of all the work, Robert, you especially have done to sort of lead us to have this kind of technology. And I'm really excited to see where VR will take us. So thanks.
Yeah, thank you. Cool. Well, let's jump in. This. There we go. This might repeat a little bit of what Maurice just said, but I think to start sort of a justification or even an outline of where VR fits in behavioral research in our lab, why we would even consider it. I think I tried to outline a few broad areas here. I think number one, obviously, is the immersive experience of being in a virtual environment, of wearing that headset. I think that in terms of our research methods, I think that for priming, affect priming, achieving some state, I think it could be very useful. I think for certain types of ecological validity, I think that we can get a little bit closer into something like a VR headset than pictures in a survey on a screen. I think that this is an interesting place to explore really salient experiences and things. Two, I think the realistic environments, simulated environments in cases where what we want is maybe infeasible or just very, very costly. I don't know if you want to put someone on an airplane or something as a passenger. That's gonna be costly to do in real life. In VR, I think we can simulate a lot of that. So low cost environments that are otherwise maybe not feasible. Thirdly, the sort of level of control that you have over the environment. This is a real like Wizard of Oz stuff. You can really control for sound, for space, for the objects in the room that maybe themselves might be infeasible or impossible to build in real life. We have those abilities. And finally, the data collection side of it. You collect the full experience, like to the extent that you can, as a researcher, go back and replay a participant's experience in your study in real time. You can sort of virtually inhabit that space yourself, and we can overlay in that space analysis tools like heat maps and scan paths and just walking paths and annotate decisions made. So I think that there's a really rich post hoc space too in VR that we can look at. There you go. Oh yeah, so there we go. So why us? We are sort of what Maurice said before, we are established leader. I think that part of that part of that is just our organization and how we are a shared resource. But another part of that is how we use cutting edge technology. We've shown that with eye tracking, with other physio measures. Um, we, we've long been a leader, and I think we want to maintain that position. But also, why now? So VR is in some ways seems almost like a dated technology. Like it's been around for a long time. But things are changing, and probably everybody knows that. More devices are coming out. Some of the newest hardware is much more advanced than its predecessors. We really are in a new generation, I think, of head-mounted display units with cameras that can track the person wearing it. There are the space around them that can integrate with generative AI to help with that, both just the machine learning side of things, machine vision, I think, has got a lot better, but also the generative AI side. And we'll be touching on that through this whole thing because the two are really intertwined. So it's a good time, and the hardware itself. This is consumer electronics hardware. It's available. We're not using any just research for the most part. Anything designed for research. This is stuff we're buying from the consumer electronics world. And that's kind of where we were when Maurice and I were first talking about this. My first reaction is, okay, the hardware is great. It's pretty easy to get. The ideas are good, but how do we do this? Like, as someone who has to do a lot of the software development side of things, like, do we need to have in-house game design expertise? Do we have to hire consultants to do our 3D rendering, to build up, who are experts in game engines and things? Because that's the technology we're using, and frankly, we don't have that here at Wharton. How do we engineer the hardware interfaces with all these different headset units? So I was apprehensive how we're going to build, use VR gaming technology and apply that to experiment designs, which has its own conventions. We might want, trials within an experiment. We have independent variables. We want to do random assignment. We need to make these worlds kind of fit together. And how much code are we going to have to write to record, then everything that we're going to need. So doing some research, we found this company, WorldViz. So WorldViz has a product called Vizard. It's software development tools specifically for research and training purposes in the VR space. This started out of the psych department at UCSB, who was working with University of California, Santa Barbara, who was working with people who were working with MIT at the time. This is probably back in the 90s. They spun off as a company in the early 2000s. And they've been great to work with. So that is our platform for building studies. And that answers a lot of those concerns that I had about how we're going to build these tools. So a lot of what we're going to go through here is a little bit of introduction to what services they provide and how we can apply them. But just quickly, there's publication history in the academic space. If you click Google Scholar search for WorldViz Vizard, lots of papers come up, not so much in a business school context. We are kind of leading here, but in lots of other fields in psychology, this software is frequently used. How does it work? So it is a development environment. You are writing Python code, but it's very high level. It's really easy. As an example here, maybe a half dozen lines of code will put you in, let me try to play this, in a space that they've already defined here. And there you go. We're already exploring a virtual reality space with just a few bits of code. Now we're not doing much in the way of recording here, where there's not much to interact with yet. But right away, you can see that the barrier to entry is really low for creating a VR space. Here we go. So on top of WorldViz Vizard, which is that environment, they've been developing a library on top of that called SiteLab. And I think it started as mostly eye tracking tools, which is why it's called SiteLab. but it adds a lot that we would need for applying behavioral research methods to VR. So what does that mean? So you have templates for eye tracking, motion tracking, the sort of video recording and other recording you might want to do. You can, borrowing from things like PsychoPy or something, like the ways that you can build trials. You can label your data. You can even use like a tabular Excel format to define trials they might want to randomize. So things that we're kind of used to using in other software development tools for behavioral research. And then all the analysis features, full replay, data exports, data visualizations. A lot of that is built into SiteLab. So now the hardware. I mentioned already the head-mounted displays. We have right now some of these Hewlett-Packard Reverb G2 Omniceps, and we're just getting started with the Meta Quest Pro. We just have one of those right now. Input devices, they come with things a lot like this. You usually one for each hand. You'll see some pictures that I bring any.
Robert, could you just say a little more about what the hardware sort of is? So like the head-mounted displays, are those goggles? Is that the goggles you're putting around your face?
Oh yeah. So yes, those are the goggles. That's what fits over your face. That's the display port through which you experience the virtual world. That includes some speakers positioned near your ears. That includes some outward-facing cameras to scan the room you're in and you. So we'll talk a little bit more about tracking the person, because that's one place where I think there's a lot of innovation right now. So it's that, and that thing you put on your head, and you usually have to connect that to a computer. You are sort of tethered, and then it usually involves hand controllers that have a bunch of buttons so that you can interact with the world, and all that's programmable within WorldViz, like what a button might do, for example, to move you around a world, to interact with objects in that world, to even answer form fields. We can put Likert scales in it. Not that you necessarily want to do that, but we can do things like that within the experiment. Yeah, so usually it's like three things: two handheld devices and a headset you wear over your eyes, and they're built with the display and then sensors are really kind of the three main categories. I mentioned heart rate. There are heart rate monitors built into some of this stuff. You can also integrate external things from Biopack or Shimmer if you want.
This is Bob Meyer. I have a question. I think that in some sense you can kind of think of this as a evolution, because I remember we were playing around with it. We had some MBA students who basically was trying to play around with building VR experiments. This is like several years ago, and actually some of that got implemented in one of our courses. And anyway, so in some sense, what it is that you have kind of, I've thought of this as being a continuum going all the way from, let's say, basic is Qualtrics survey, okay, which is kind of where we are now, and then the other extreme of this is true full virtual reality, where people have headsets on and they're in virtual worlds and so forth. And there's a lot of stuff that's kind of in the middle. That, for example, like a classic problem in a lot of marketing experiments is to do something like, I'm interested in how people choose things from a store shelf, where I don't necessarily need for them to have the full headgear on, because, like, for example, when you started off, you showed dynamic immersive navigation, which wasn't with a headset. It was just a movie of like walking around a square. And so for example, would this allow people who maybe don't want to necessarily go with the full headset, but still want to be able to do things that are immersive, in which you could basically, let's say, but it would be on a computer as opposed to a headset. So for example, you could do something where looking at a store shelf where you could go in and you could take products off the store shelf and look at them. Okay. Is there capabilities for doing something like that?
Yes, and in fact, all of the recordings that I sort of embedded in this PowerPoint were done, as you noticed, just on the screen. So you can,
okay.
The screen itself is a valid display device. So you could use headset or just the screen. I have examples, I don't have them here, of exactly what you're talking about, navigating a store, looking at products. I guess one thing we might not always have, if you want eye tracking with that, I'd have to see if we could build that in. But
yeah, okay. So I'm sorry to interrupt. I'll let you go on, but I just had two quick questions. One of which is, one of the problems that we had when we were doing it was we had like a virtual living room. Okay, so that was the standard setup, and you could go and you could turn on the TV, you could go to a computer, you could leave the room. And so here, one of the problems, if you wanted to do anything other than the virtual living room, you could in principle develop it, but it was really difficult. So here, is there like an established catalog of environments? Or let's say if you wanted to do my neighborhood in Center City, okay, like, like if we wanted to do that, or is it a standalone catalog of places, of things that you can, that you could pull up?
there are vast quantities of many catalogs of 3D environments that you can get for free, you can buy. They're also increasingly easy to generate with, I'll actually going to demonstrate soon, with even your cell phone. It's not the best quality, but with like 360 cameras and things, we can build environments for yes.
Okay. Yeah, I also was thinking that I guess, I don't know, coming pretty soon. Well, it's already there, but coming pretty soon is Gen AI video, and so that could also be something that would help with that.
That's already available. Yeah.
One other question, I'll let you go on, is another thing that was a feature of that thing that we did, which is I think of interest to a lot of people, and you had briefly mentioned this, is sometimes what happens is you want to be able to get like report measures as the person is going through the task. And so, like, for example, as soon as they click on a product, to be able to like go to a quick survey that said, what did you just think of that product that you just sampled? Okay, and then you can go back to it.
Yeah, that is built into SiteLab. It can either be where it fully interrupts their experience and just shows them a very two-dimensional screen, or it can be a thing in the environment that allows that they can do it with, if that makes sense.
Okay.
Yes. Cool.
Okay, that's it. I'm done.
Great. We talked a little bit before about the devices, and Maurice was asking so here's a picture of the Tobii with the HP. I mentioned Tobii here. They're the eye tracking company. They're probably one of the industry leading eye tracking companies. Their technology is built into the HP headset, which means they have a really good eye tracking API, a really good pupillometry API. Where it's a little weaker, the face camera, it's a single face camera. You can get some information from it, whether someone's smiling, certainly whether they're speaking, and then use that to, say, animate an avatar, but not as rich an environment as some others. And there does have a built-in little heart rate monitor. Compare that to the Meta. It has an eye tracking API. It's not as good. The data's not that great. There's no pupillometry. The face camera is much better. They've built in action units for face tracking if you're interested, if you want to do like emotion or other measures using that. I mentioned kind of in bold down there, the hand tracking is really cool. You can drop those controller devices and sort of track your hands in the virtual space to interact with things without having this mediator of pushing buttons. You can sort of reach out and touch. It's a little tricky to get the geometry and physics not to work, but it does work, and it's a much more immersive experience. And this has augmented reality. You can feed in the external facing camera. I have not tried anything with that yet, but that's another area that we can look into. And the Meta Quest has that.
Robert, can I ask you, can these connect to each other? So if you put one on and I put one on, could we interact with each other?
Yeah, yeah, and we'll talk more about that as I go on here. But yes, multi-user designs are possible.
And is that better with the meta version because of the face camera?
Well, I don't know for sure. We'll look into that. If what you want is, say, someone to express emotion with their face, with an, in a dyad with another person, I think that yes, the meta would be better for that because we'll have more real-time information about what's happening in their face. And then can use that to trigger events in the face animations or morphs. So I think the choice of hardware will slightly depend on the measures you want to collect. So just quickly, I'll go through virtual reality environments, the environments themselves, objects in those environments, and the avatars. So environments can be 360 images or video. This is a really low barrier to entry. You can record this room we're in right now in a matter of minutes, load that into SiteLab or load that into WorldViz. You can even use phone apps to do it, but really a 360 camera I think is a better option. You can get them for around $500. One thing to note about this, your point of view in this world is fixed. You inhabit the space that the camera was sitting in. Now, the camera could move, you could put on top of a car, do something like that, but I can't move around a space in that 360 media. I'm sort of anchored where the camera is anchored, as opposed to rendered in spaces where you're actually, everything's a 3D model. Those are the spaces you can move through. You can build custom, it's just open scene graph. That open scene graph is the standard that Wizard uses. In addition to the code IDE, there's something called Inspector I'll show a screenshot of, which allows you to manipulate the models. There's other software, there's Blender, there's lots of things. With some are easier, some have lower learning curves, some have much steeper learning curves. It depends on how much you want to how much control you need over rendering the spaces. As I mentioned, there are many catalogs of spaces that you can go online. Sketchfab is a website you can go to and just download rooms. Some of them might cost $5, some of them might be free. And you can use AI to generate. You can describe a space and have AI generate it. And I'll show some examples of all this. This is just what the inspector looks like from Wizard. What I've created here is just a small white room, kind of similar in size to the breakout rooms we have in the lab, with a table in the middle, similar to what we have in our lab. What you see on the left is a representation of that scene graph. It's hierarchical. And then on the right, properties of the different elements. At first glance, it's kind of busy, but it's pretty easy to figure out what's going on here. I use this to do, I don't know anything about, honestly, 3D modeling, but I can go in here and build at least something as simple as this very easily. 3D, so if you are from the lab, you probably recognize this kind of cluttered office. This is where Bob and I sit. I use an app on my phone to generate play on this, like a spherical stitched together thing. So you'll see lots of seams because it's all stitched together, but I was able to create this with a free phone app in like no time at all. So I can just very low barrier to entry to creating things like this. And if you want to know why Bob's bike is in pieces, you can ask him that for a meeting. It's a good story. Yeah, yeah. So creating objects, just like environments, they're the same thing. They're 3D models that just exist in a different place in that open scene graph hierarchy. You can create simple polygons with just 2D JPEGs. So for something like that Bob might want to do with packaging, you could sort of have uniform shapes with just different pictures and corresponding to different packages. Since that's easy to make in the Wizard software itself. And there's the algorithmic creation tools. Now that's algorithmic in the sense of machine vision. Like that's what I pretty much used to create that 3D video or 3D image of my office, or more next generation generative AI, just describe what you want. Here's a quick example. This is my coffee mug. I drink coffee from in my office every day. I used a phone app to scan this mug. This is, so it's a little clunky, a little chunkier version. And here it is now in that room that I had built, sitting on the table in a in a virtual space. And I think I'm going to try to pick it up with the controller there. It's a little hard to hit. There we go. I got it. And I don't have the physics set up to not go through the floor, but there it is. That, you know, took a very short, very little effort on my part to take a real object and import it into the space. Now, here's a quick demonstration using, this is purely using generative AI. This is one of many websites I think you can go to do this. I described basically that same mug, a coffee mug from Franconia Notch State Park gift shop, and it came up with some slightly less cool versions, but I was able to download that and put it on the table with mine. So here we have a real mug scanned and an AI generated one existing in the same room. With very little experience on my part on how to do this. So then to avatars. Again, similarly, these are 3D. We can spend a lot of money having somebody build things for you. There are a lot of companies that will, again, most of these companies make these things for video game designers. So you'll find the gamut of realism to non-realistic. This is one of the, I think, higher cost but higher quality providers, Real Illusion. You can give it photos and it will use machine vision, machine learning, and AI to try to create something that will be highly realistic and work in your space. To make changes to these, I think does require some level of expertise and probably some additional software. So Real Illusion is one option. Rocketbox Library is another that's been around for a while. That was specifically designed for academic research. So if it's maybe a little dry, a little duller than some of the options from other vendors, but this is a free open source library. Microsoft owns it. And for replication purposes, for other things, I think this is probably pretty, there's there's a lot of established use of this library in research. And there's others, just like Ready Player Me and Avatar examples of easier to use, slightly less sophisticated, that also can start with pictures. They tend to be a little more cartoony, a little bit, again, more geared toward the video game environment, but very useful, very usable for us potentially. Okay, so VR paradigms. So one person sitting at a computer or wearing a headset. And then as Maurice was asking, yes, we can do multi-person networked. So this all would happen over like Ethernet. So we have different computers running. We run one as a server. We run a server, and then different clients can connect, and those avatars can all be in the same space. Sound isn't necessarily built in. We've had some success using Discord as the sound server. That's technology that I get that is used a lot in the gaming community to talk while gaming. Works really well in this context as well. We can also record, transcribe, do a lot with the voice. RA observer image. So in that multi-user space, you might want a sort of fly on the wall RA who's maybe not visible but watching things, and we can set something like that. That you can have an RA be the other person, maybe as a confederate, and you can even use AI to animate and inhabit an avatar in a multi-user space. And I'll show an example of that a little bit. And so research paradigms, so interaction with objects and environments, visual search stuff. I was already thinking about Bob before. I think lab stores, I think looking at items on shelves in this kind of world is a really good application. Puzzles and other tests, cognitive load tests or something, if you want to do that. Then something I think about Maurice's research a little bit more, altering avatar characteristics and independent variables related to appearance, how you interact. not only appearance, but we've done some testing with voice modulation using some AI tools from 11 Labs, and there's another one I forget, but real-time voice manipulation to make you sound like maybe to have a control voice or to make it just sound, change maybe the perceived gender of your voice or something. Immersive experiences we brought up early on, and really this is where we're looking for more feedback from our research community. What else can you imagine doing with this technology? How do we run studies? We haven't done it yet. We don't know. We know some things, but we're working out protocols, how much overhead, how many RA personnel we're going to need in the lab. Are glasses going to be a problem? Other subject traits we have to screen out on. We're working through the nitty gritty on that. So we do have ways to label with your behavioral lab ID, that sort of thing. Do recordings. We can display instructions. We can again, as Bob was asking before, we can display scales and survey type form fields while in the space. And there's some standard pre and post questionnaires about embodiment, about the experience that I know that we might want to consider adopting. Data quality, we don't know what that looks like yet, but that's something that we want to be very mindful of and develop good protocols for establishing data quality. And then recording WorldViz saves all data, all movement data. As I mentioned before, there's enough that you can fully replay the whole experience post hoc. And you can also do screen recording. That's a little simpler. You just get a video of what they saw. We can do lots of data visualizations. We can superimpose those visualizations in the space, like static heat maps or scan paths of the eye tracking. And we can do AOI-based analysis, like area or region of interest. We can select objects as being a region of interest, whether that intersects with the gaze or with, say, some other manipulation, like they picked it up or looked at it, they turned it around, they did something with it. All of that can be built into your study and recorded as data. Then we can also just do raw data exports, lots of XYZ or Euler coordinates. We can dump out thousands and thousands of those. So here's an example of a kind of postmodern art gallery space. The task here is to find a painting, and this is a replay of that. So the floating head is the original participant, and then our point of view is the replay point of view, which you can move around. So I play here. See, I did the static scan path as the floating head is looking through. And then you'll even see down the bottom the what painting they're looking at is changing. That's like tying to labels built into the paintings. Found Starry Night, task complete. So here's hopefully the sound works here. I was working with the site lab engineers to build a demo here where we wanted to see if we could interact with an AI, with an avatar that used ChatGPT to respond to us. So the setup here, it's a used bicycle sale negotiation. The implementation is that we use, we have to transcribe what I say to text. We have to then supply that text to ChatGPT. We then take what ChatGPT responds and synthesize that as a voice, and then play that back and animate the avatar. Right, and we give the ChatGPT assistant a prompt. We tell him that he is selling a bicycle. He has some parameters for negotiation and prices. Let's see if this works.
Hi, my name is Robert. I'm here about the bicycle you posted for sale.
There's going to be delays in his response. That's something we're working
Hi, Robert. Great to meet you. Let me show you the bicycle. Do you have any questions about it?
It looks nice, but those tires look old. How much were you asking for the bike?
Look at that.
I'm asking $1,000 for the bike. The tires are in good condition, but let me know if you have any concerns.
Yeah, I think I'm gonna need to replace them. That'll probably cost me about $100.
I understand your concern about the tires. Considering that, would you like to make an offer?
Yes, how about $900?
$900 sounds fair, considering the tires. Let's do it. Are you okay with that?
All right, so I should have gone lower first because he would have, I did a few tests, he will reject, below the price I gave him. We also tested this a little bit with like Claude and ChatGPT. There were a little bit of discrepancies. And then there's that delay. I'm working on a lot of that. It's just some of that transcription stuff is actually pretty slow, and I'm working on speeding that up. But it's a fun proof of concept to like interact with this, totally synthetic AI in that space. So where do we go next with this? What topic or paradigms that we've gone over? Where should we focus? Where should we be putting our attention? What's general enough that we can build out templates and things that are easy to use? It's like a lab store, the thing that we really should have a ready to go template for. Or is this not even enough? Should we add more things? So all of this is a participant really sitting in a chair with a headset on or in front of the screen. Do we want to add movement on the participant side, which would include full body tracking? All of this is possible. Do we want to bring in the augmented reality stuff? And I mentioned finally cave rooms, which would be a big investment, but these are rooms with, say, projections on all four walls, maybe ceiling and floor even. But ultimately, it's the same kind of thing. You're still in a VR space, but not wearing any hardware. Your movements are being tracked by cameras or LiDAR, and the projections itself are, and WorldViz does this. I was in one of the rooms they built. It's very cool. It's a really, really cool experience. Just want to thank Maurice for all this. Sato is the engineer at WorldViz who really helped, especially with that AI one. And Bob, who handles all of our hardware. Thank you so much. Questions? That's the end for me otherwise. Yes, Seth.
How does WorldViz work? Is it a licensed subscription? Is it
Yeah.
something that we have to access through WBL? Like what?
You would probably just borrow a laptop from us that has a licensed version of the software on it, or we would just provide you with a license key and you would install it yourself. It does help to have a machine with like dedicated GPU and it has to be Windows. So we're using, actually this is one of our laptops. We're using these gaming laptops with NVIDIA GPUs on them. And the GPUs are proving useful too for some of the optimizations I'm trying to make for the AI stuff. We're using the CUDA libraries to try to speed up all that. But yeah, and then we pay annual support. We have it's per machine. Anyone online? Was there anything in chat? No. Well, thank you. And
Oh yeah, so I would just say, Robert, thanks so much for bringing this and sort of creating this, sort of bringing virtual reality into our reality. I'm extremely excited about this technology. I'm also, like I want to sort of dip our toes in. I think we should be in this space, and I'm eager to see how we move into it. My thinking is for us to start off with the technology that we have and see what sort of interest there is. But I'm eager to hear, from, colleagues, and like people, as you're interested, if there's interest in like full body or other kinds of things, I'm really eager to hear about that. My initial thinking is even just having people seated at a table, or sort of if they could walk down an aisle and pick out cereal boxes. I mean, relatively simple things, I think, is where we should start, but I'm like receptive to other scholars and sort of like what their interests are as we go forward. I would say personally that negotiation experience is pretty neat, and I already have a bunch of ideas for ways to build on something like that. So this has been really, really interesting to me. I'm very grateful for all the work you did and the travel you took to sort of understand this technology.
I got to go to Santa Barbara. It wasn't that bad.
Yeah. Anything else from anybody online, or anybody, they're in the room?
And nobody in the room.
Well, it's not nobody.
I mean, there are people in the room, but no one's raising their hand.
Well, great. Robert, thank you so much. Thanks to the whole Behavioral Lab team for supporting all of this, and for Wharton Research Computing for being such a great partner as we go forward. So I'm very excited, and thanks for pulling this together, Robert. Thank you.